Now let's solve this problem. A separately excited generator when running at 1000 RPM supplied 200 ampere at 125 volts. What would be the load current when the speed drops to 800 RPM? So if IF is unchanged, given the armature resistance of 0.04 ohm and brush drop equal to 2 volts. Okay? So let's just analyze a problem. First things first is to know what kind of generator you are solving. So you are solving a separately excited generator. So it makes sense that we can solve for our value, or we can solve for the value of our IA. Okay? Upon solving for the IA, we can solve for the EG. And the EG will be used in order to solve for our EG2 and the load current at 800 RPM. Okay. So from here, we have a separately excited generator. So therefore, when you are solving a separately excited generator, the field coils are separate, right? So therefore, there will be a different IF that is separate to the circuit. Okay? And then of course, we have our EG, positive, negative EG, and then our voltage drop VBD. In this case, this is equal to 2 volts, and this 2 volts is the total voltage drop. But if the problem has a statement per drop, you would multiply it by 2. Okay, unless a number of brushes are given, which is 4, 6, or 8, at least you would multiply it by 2 if the number of brushes are not given. Okay, next is our RA. Okay, next is our terminal voltage. Okay, wherein our terminal voltage VT is equal to 125 volts. Now, from here we have our VT is equal to 125 volts, and this is, okay, the load is consuming a current IL equal to 200 ampere. Okay, now that is the load current. Now this is the load current at 1000 RPM. Now the question is, what will be the load current when the speed drops at 800 RPM? So what do you think, right? Is the load increase? Well, will the load current increase, or will the load current decrease? Now let's find out as we solve this problem. Now we have 125 volts. So in the problem, it does not it did not state, or the problem did not change the load into statement. So this is still the same load that you would solve at 800 RPM. So the tendency is that the constant value in here will be the power rating, right? So since there is no power that is already given into the problem, so therefore we may solve for the resistance of the load, which is given into BL is equal to IL multiplied by RL, wherein our IL is the current that is entering the load and our VL is the voltage in the load, or the terminal voltage. So therefore we'll have 125 divided by 200 is equal to our RL. So our R load will be equal to 125 divided by 200. This is equal to 0.625 ohms. Now, from this, we may solve for our EG. So, solving for EG. So, if you would solve for EG, the next thing to do here is, of course, to take KVL. Okay? So, take note that our RA is equal to 0.04, and of course, there will be an significant VA. So from here, if I would take KVL, we'll have negative EG plus VBD plus VA plus VT is equal to 0. Take note, our VT is equal to our VL. Now from here, I will have my EG, which is equal to VBD plus VA plus VT. But what is my VA? My VA is simply equal to IA multiplied by RA. and my IA is equal to, now, our IL is in series with our IL, so therefore, IL is equal to IA, which is equal to 200 ampere. So 200 multiplied by 0.04, which is equal to 200 multiplied by 0.04. So this will be equal to 8 volts. Okay. Now, from this, we'll have a value equal to my VBD, which is equal to 2 volts, plus VA, which is equal to 8 volts, plus VT, which is equal to 125 volts. So therefore, our EG will be equal to 135 volts. Now, we have already our EG at our 1000 RPM speed. The next thing to do is, of course, to get our EG at 800 RPM in order to compare the current at IL. Take note that the brush drive will always be equal to 2 volts whatever the current that would enter to the circuit. Okay, it would not change. Now from this, I will have, see, at 800 RPM, right? So we have our EG1 over EG2 is equal to, based on our discussion, the only characteristics that we can, or the properties that we can change if we would not rewind the generator is its flux and its speed. So V1 N1, V2 N2. Now since IF is not changed, so therefore we may understand that our V1 is equal to V2. Okay, so this is constant. So from here I may solve for my EG2, which is equal to EG1 multiplied by N2 all over N1. So from here my EG2 will be equal to EG1, which is equal to 135 multiplied by N2, which is equal to 800 all over 1000. So therefore we'll have 135 multiplied by 800 divided by 1000, which will yield to 108 volts. Now since we have our 108 volts at EG2, okay, so therefore this will be 108 volts. Therefore the terminal voltage will the IL or the load current will change because of the significant drop of my EG. Now since EG drops, IL drops, so therefore our terminal voltage also drops, right? Now from here, if I would take another KCL considering at EG2, okay, so from here would consider our 108 volts instead of 135 volts. So therefore, setting size fans. So from here I will have EG, negative EG plus VBD plus VA plus VL equals 0. This time our VL is not equal to 125. Okay. Now from here our EG is equal to negative 108 volts plus 2 volts plus our VA. Take note that our VA is equal to IA multiplied by RA, which is equal to 0.04 ohm, plus our VL, which is equal to IL multiplied by our RL, which is equal to 0.625 ohm, which is equal to 0. Okay, now since IL is connected directly with our IA, so therefore I may say that IA is equal to IA. So therefore I will have negative 108 plus 2 will give you negative 106 plus 0.04 IA plus 0.625 IA. equals 0. So therefore we have 0.04 plus 0.625. We will have a value equal to 0.665 IA, which is equal to 106. So IA will be equal to 0.665. So 0.665 divided by 106, I should say 106 divided by 0.665 divided by 0.665. It would yield to a answer of our IA equal to 159.34 ampere. Okay, 0.398. Okay, sorry. So that would be our answer.